Okay, in this video I'm going to show you how to use the properties of a natural logarithmic function to manipulate expressions involving the natural log function, either to simplify or to write in terms of logarithms of the simplest expressions possible, or possibly evaluate expressions even without using a calculator. So what I'm going to use in these three problems I have here are these properties of a natural logarithmic function. First, the natural log of a product equals the sum of the logs of the factors individually. The log of a quotient is the difference of the logs, so the log of a numerator minus the log of a denominator. The log of number raised to a power, you can pull the exponent down, so it's equal to the exponent times the natural log of the base. And finally, certain logs are easily evaluated. The natural log of 1 is 0, and in fact, the log of 1 in any base is 0. And then the natural log of e, which is the base of the natural logarithmic function, is equal to 1. So the log in any base of that base is equal to 1. This is another way of saying that anything to the 0 power is 1, and any number raised to a first power is itself. Okay, so now we're going to use these properties to work out these three problems. First, I'm going to take this expression and expand it into sums and differences of logs of the simplest expressions possible. And the important criteria here is that no logarithm in my final answer should have an exponent anywhere in it. The second problem, I'm going to condense this into the logarithm of a single expression that's as simplified as possible. And here I'm going to evaluate this expression to get an actual number without using a calculator. So for the first one, we have a log of a quotient first and foremost. So I'm going to use the second property. The log of a quotient is the difference of the log. So log x minus the rest, log of the square root of x to the 4th y squared. But this is the same as x to the 4th y squared to the 1/2 power. So if I write it this way, then I can use the third property and take this exponent and put it out front. So then I have 1/2 natural log of x to the 4th y squared, well, it's under the square root sign. Next, what I can do is I can take natural log of x to the 4th y squared, and that's a log of a product, so I can write that as a sum of those logs. So I have ln x minus 1/2, and I'm using parentheses here, so be careful about that. Natural log of x to the 4th, natural log of x to the 4th, plus natural log of y squared. And now, in each of these, I can use the third property, as I have something raised to a power, so I can pull the exponents down in each term. So I have natural log of x again, minus 1/2 again, and then I have in here 4 natural log of x plus 2 natural log of y. And now I can distribute, well, first of all the logs are as simple as can be. So there's nothing more to do there. Now it's just algebra at this point. So I can do natural log of x, and I distribute the minus 1/2 through all this. So I have minus 1/2 times 4, which is 2 natural log of x, and then minus 1/2 plus 2 is minus 1 times natural log of y. And finally, I can combine the first two terms, ln x minus 2 ln x is minus ln x minus ln y. So that is the final answer for that first one. Now for the second one, we're going the other way. So we have a difference of logs, and we use this property in reverse. A difference of logs is the log of a quotient. So this would be the same as natural log of x squared plus 6x plus 8 over x plus 2. So it's the log of that entire quotient. But now we need to simplify, if we can. So the numerator can be factored. X squared plus 6 to x plus 8 factors into x plus 2 times x plus 4. There we have over x plus 2. So the x plus 2's cancel, and we're left with natural log of x plus 4. So that is the final answer there. Finally, the last expression, we're going to evaluate this by using the properties of logs, in particular the exponent property. So we have natural log of the 7th root of e to the 5th. So we're going to rewrite that as e raised to a power. So that would be e to the 5/7. So whatever root you're taking, that goes in the denominator of the exponent. The power underneath, that goes in the numerator. So e to the 5/7. And now we can use the third property. We can take this exponent and pull it down. So that's 5/7 natural log of e. But the natural log of e is 1, so we're left with just 5/7. So we see how to use these properties literally backwards and forwards.